So the first observation I made was that when you see this exponent, I knew that if I were to multiply it by its conjugate, first of all, this will be a difference of squares, would be an integer. But in this particular case, it would become exactly 1. And that happens often. And that means that if I just observe the answer choices and start with b, which is x to the power of 7 minus 4 root 3, what we're really doing is raising this to the power of this product, which we know already is 1. So that means this one will not be the answer because that's equal to 4096. Now next I was kind of looking for where else do I get this 7 minus 4 root 3. And you'll see that that will come up here as well because it's just the same number, but the denominator of 2, because this is 7 minus 4 root 3 over 2. So when we replace that x with this becomes 4096 to the power of 7 plus 4 root 3, 7 minus 4 root 3 over 2. This piece we already know is 1, so we're really just looking to see, is that the square root of that equal to 64, which is indeed, if you were to use the calculator or multiply that. And that's how I spotted the answer, which is C. So it's a little bit of trial and error, recognizing this property and then simplifying it. I mean, some of you may have to go through the other ones. For example, if we were to do choice D, this would become 7 root 3 minus 8. Okay, so this is kind of messy. Clearly would not come out to be a nice integer. So I would set that aside, maybe come back to it. Last one is, sorry, the choice A is 7 minus 2 root 3. And again, if you multiply it by 7 plus 4 root 3, you'll see this is not a whole number. So you can also, when you see 4096 and 64, maybe try to establish that relationship. So there's a little bit of a trial and error here and spotting the different answer choices. So it's not a completely direct path. So to summarize, the answer is C.